Alright, welcome back everybody. In this video we're going to look at the first couple of examples from the implicit differentiation lesson to help us understand the process of implicit differentiation. Now when we use implicit differentiation, all we're really going to do is take the derivatives of these things. What makes this implicit differentiation is this is a function that we cannot solve explicitly for y and get y equals some function of x. And therefore we have two variables that are occurring in our differentiation. An important thing that we have to keep in mind when we take these derivatives is that we have to apply the chain rule and all of our other derivative rules really as they show up in this particular context. So let's go ahead and look at example 1. We're going to find dy dx if x to the third plus y to the third minus 9xy equals 0. And so I'm going to go ahead and take the derivatives of these things term by term. The derivative of x to the third, if I take the derivative of that, is going to be, and we're applying the chain rule here, it's going to be 3x squared times the derivative of the inside. And the derivative of x is dx dx. This is something we haven't really talked about up until now because every time we took the derivative of an x, the derivative was dx dx. And dx dx is going to be 1, and so since we're multiplying by 1, it simply goes away. But now that we're bringing in the concept of implicit differentiation, this mindset is going to be important to apply in other scenarios like the next one. We're going to take the derivative of y to the third. And the derivative of y to the third, the derivative of the outside, leaving the inside the same, gives us 3y squared, times the derivative of the inside, the derivative of y with respect to x, which is going to be dy dx. And now on this next term, minus 9xy, we've got a constant multiple, and we've got two things that are being multiplied together that we're going to need to use the product rule on. We've got minus 9, the constant multiple, so we're going to take that times the derivative of x times y. The derivative of x times y is x times the derivative of y plus y times the derivative of x. And all that is equal to the derivative of 0. Now as I mentioned, the dx dx's become 1, and so in my next step I'm going to replace dx dx with 1, and I'm going to distribute the 9 through the parentheses. Go through this. And now I'm really done with the calculus from this. It's all algebra from here. We want to use appropriate equation solving techniques to solve this for dy dx. And in this case, that means we're going to subtract 3x squared from both sides and add 9y to both sides to get the 3x squared and the minus 9y off of the left-hand side. Then we're going to factor dy dx on the left-hand side once all the terms that are left contain a dy dx. And then we're going to divide both sides by 3y squared minus 9x to get dy dx by itself. And the only thing that I now need to consider is, can I simplify what's on the right-hand side of this equation at all? And every term in both the numerator and denominator, I can factor a 3 out. So I can factor those 3's and cancel the 3 from the numerator and the denominator. And we end up with our derivative. Now notice when we do implicit differentiation, it's not unusual. In fact, it's pretty common for our derivative to contain both x and y once we're done taking the derivative. Alright, let's go on and look at example 2. We're going to find dy dx if 2xy plus y to the fifth equals 3x squared. So first, I'm going to take the derivative of 2xy. Got a constant multiple 2 which will multiply times the derivative of x times y. The derivative of x times y is x times the derivative of y plus y times the derivative of x, which is just going to be 1. And now I take the derivative of y to the fifth. And here I need to apply the chain rule. Derivative of the outside, leaving the inside the same, times the derivative of the inside. And all that's equal to the derivative of 3x squared, which is 6x times the derivative of x, which is just 1. All right. It's very important that we keep this chain rule mindset going when we're doing these, because if we don't, we're going to end up without a dy dx in our derivative, which makes it very difficult to solve for dy dx. All right. So I'll distribute my 2 through my parentheses. Subtract 2y from both sides to get only dy dx terms on the left. I will factor my dy dx out. And then to get dy dx by itself, I'm going to divide both sides by the factor of 2x plus 5y to the fourth. And that gives us as our derivative 6x minus 2y over 2x plus 5y to the fourth. Alright, that's the end of this video. We'll come back and look at the remaining examples from this lesson in the next video. See you then. Hope you have a great rest of your day.